Hello friends, welcome to my YouTube channel. This is Malav Doshi DGTKT. So today I'm gonna attack the concept of polynomials of class 10th. So you might have been gone through the basics in class 9th. So first of all, let me revise you the basics. The general form of polynomial is something like this, which you might have seen in your textbooks. So here an, never ever think that an means a multiplied by n. No, it is denotion that this is the nth term. For example, here I have written a1, so it is the first term, a1. So here x raised to n, this is the power. So here there is a condition that n cannot be equal to 0, because then there would be no polynomial. So, and it cannot be negative also, or negative. So here n should be a real, not a real number, a natural number, that is set beginning from 1 to infinite. So for an instance, take that n equals 3, just an instance. So here we would get a3 x cubed plus a2x square plus ax plus a0. So here a0 would not be equal to 0, because here a0 x raised to 0 is there, therefore x raised to 0 is equal to 1. It shows that this is the constant term. This is the constant term. So here the degree decreases gradually. Okay, now let's come up with the first topic, which is graphical representation of zeros. Now let's say we have a polynomial p of x square minus 2x plus 1, just a polynomial. So here, now how would the graph of it would be? It would be either of these three cases, either intersecting x-axis at 2 points, at a single point, or not intersecting. Okay, so here the degree is 2, therefore maximum zeros that can exist of this polynomial are 2. Maximum is the maximum degree of a polynomial, the zeros are there. Now let's see the three cases. If the parabola, the graph of this type of equation which are not linear, is known as parabola because they have curves in them. So here first of all see that which polynomial is given, p of x or p of y, because if here it is p of x, therefore we have to see that where parabola intersects or cuts x-axis. Here if it cuts y-axis at any point, it doesn't matter, but here if it is given that py is equal to y square minus 2y plus 1, then we have to see the inverse case. We have to see the y-axis. Okay, so this is one of the condition. Now here p of x is x square minus 2x plus 1. Now for an instance, just keep it aside, you have a graph here, this type of, that this parabola is intersecting x-axis at 2 points, and you are asked that tell the number of 0 of polynomial px. Now you are asked of px, so see at how many points parabola is cutting, 2, therefore it would have 2 zeros. Similarly here 2 zeros would be different, 2 zeros can't be same, 2 zeros would be different. Okay, now here if this parabola cuts x-axis at only 1 point, now here there are 2 roots. Roots would be 2 because you need 2 factors for making this polynomial. You need 2 factors. Without 2 factors you can't make the quadratic polynomial. But here the case is that the 2 roots are equal. For example, here we have roots 2 and 3. Then the factors would be x minus 2 and x minus 3. But here both the roots are same. So in short, it is a squared form. The 2 roots are equal, therefore there would be only one 0. 0 is which makes this polynomial 0. And since both roots are equal, there would be only one real 0. Now, the third case, where the graph don't cuts at x-axis. So what you will do? So this polynomial doesn't exist? No, it exists. The example of it is x squared plus x plus 1. Now here it's a condition. See, I have written no real zeros or no real roots. This type of equation or this type of graph have imaginary roots in form of iota, where iota equals root of minus 1. Now if I simplify this using the Sridhar Acharya method, I will get minus 1 plus root 3 iota upon 2 and minus 1 minus root 3 iota upon 2. So here iota exists, therefore there are no real roots because iota equals root of minus 1, which doesn't exist. So similarly, if you get a graph where it is not cutting the x-axis, then you have to just write that there are no real roots or real zeros. Okay, now here I showed you for quadratic. Let's see about cubic polynomial, that how graph of cubic polynomial or parabola will look. So here let's say that in cubic polynomial there are 3 different zeros. Therefore the parabola will intersect at 3 different points. Okay, so here will be 1, 2 and 3. Here it is 1, 2 and 3. Okay, now similarly I will show you one more case where no real roots exist. Here see, here it is not intersecting the x-axis, therefore no real zeros. Now your task is, I have shown you the 2 different cases in it, and you have to identify or you have to make the different cases for this cubic polynomial yourself there, so that you can practice. As there are 3 cases here, in cubic polynomial also there would be different cases. I have shown you 2 of them, so now your homework is to just take out another 2. Now let's come to the main topic, that is of coefficients and zeros of polynomial, between zeros of polynomial. Okay, and I want to inform you that click on the I button above. The poll is going on and you can select the topic which you want me to explain in the further videos. So now let's begin it. Let's take quadratic polynomial. You all might be knowing the general format of quadratic polynomial is ax square plus bx plus c. Okay, you all might be knowing. Now let's say that d and e are zeros of this. In your textbook it is alpha and beta, but I would show it alpha and beta, but alpha and beta are not having any values. They are just representation. They are also variables. They are the alphabets of Greek alphabetical order. So let's do with alpha and beta only. They are representation. Don't get confused that alpha and beta have any values or like that. You might be familiar with alpha, but beta is the same. So here, as you know, that ax squared plus bx plus c. So there are at max 2 zeros, as I said you. Okay, so there are at max 2 zeros. So let's say alpha and beta are 2 zeros. Now what you know, that if alpha is 0, then x would be equal to alpha. Therefore x minus alpha is one factor. Similarly, x minus beta is another factor. Okay, alpha and beta are 2 zeros, therefore x minus alpha and x minus beta are 2 zeros. And if you don't know this and want to learn reminder theorem, click on the I button. Reminder theorem's video is given there. You can go and visit there. So here now let me ask you that if you have a number 12 and it is given that 4 and 3 are factors, therefore you can write that 4 into 3 is equal to 12. You can write like that. Similarly, we can here write, we know that x minus alpha and x minus beta are factors of the ax square plus bx plus c. So we can write that x minus alpha into x minus beta equals ax square plus bx plus c. Okay, now here it is a k constant. Now what is this constant? Let me show you. If there is a polynomial, that for an instance take that there is a polynomial whose factors are x plus 1 into x plus 4. Now what here you can see that 2 is common. Okay, so what you will do, take out that 2 common and you will take out that 2 here. Alright, similarly if any common digit is existing here, then it would be taken out common in the form of k. Now here if k equals 1, directly x minus alpha into x minus beta would be equal to x square plus bx plus c. Don't worry, now you will be worrying that if we will write k, the value will be differ, or like, no, value won't be differed because k will get cancelled off in the same way. So here let's write k. Now let's multiply this. We have x square minus alpha plus beta x plus alpha beta. Okay, on multiplying we will get, alright, is equal to, we know that ax square plus bx plus c. Now let's multiply with this whole k, that kx square minus alpha beta kx plus k times alpha beta is equal to ax square plus bx plus c. Now here just observe one thing, that every variable is same here. See, x square x and x square x same. So since this both are equal and x minus alpha and x minus beta are the factors of this ax square plus bx plus c, can we write like that a equals k? Because everything is same here. You can observe one thing, b equals minus k into alpha plus beta. Just take out this coefficients, this x square x. So we can write like that because everything is equal here, x minus alpha into x minus beta, because they both are factor, as therefore these two equations are equal, so both are quadratic. So we can directly say that the coefficients of this whole equation would be equal to the coefficients of this both equation. Okay, similarly c equals alpha beta, k alpha beta, sorry. So here observe one thing, I told you that, okay, that k would get cancelled. So if you take any fraction, k would automatically get cancelled. Okay, so now let's take something, let's take c by a. Then what we will get, k alpha beta upon k, which is equal to alpha beta. Whoa, we got a value. Now let's take minus b by a, because here as minus it is there, to make positive let's take minus. So therefore we will get minus k alpha plus beta upon k. Here minus minus positive, so k alpha plus beta upon k. So here we will get alpha plus beta. Voila, we got two values, that c by a equals alpha beta and minus b by a equals alpha plus beta. Now what are these values? First understand this. Here it is shown that product of roots, for example alpha and beta are roots, therefore product of these roots would be equal to the coefficient of constant, or in short the constant term upon coefficient of x square. Means here if any polynomial is there, x square minus 2x plus 1. Now take an instance as alpha and beta are the roots. Alpha and beta are the roots. Then product of this alpha beta would be equal to constant term upon coefficient of x square, it is 1. Okay, upon 1, which is equal to 1. Now if you will take out the roots by middle term split method and multiply them, you will get value as 1. It's my challenge. Now similarly here alpha plus beta, that sum of roots. If we will add both the roots, then we will get negative coefficient of x upon coefficient of x square. So let's apply that case here, that if alpha and beta are roots, then alpha plus beta would be equal to minus into minus 2 upon 1 is equal to 2. You can solve it if you want. You can solve it. So the same thing apply here, that if you multiply the both roots, then you will get value of c by a. So in exam, if it is asked that, for example, a very big polynomial is asked, for example 117x square minus 2x plus, let's take anything, 224, anything like that, you can take yourself. Now so here if it is asked that find the products of root, so now you will take out the roots of this thing. No, you can directly do that 224 upon 117. You can do directly, no problem only. You can directly write that product of roots at 224, and if it is asked that find the sum of roots, then you can directly write minus 117 is equal to 2 upon 117. So I hope this concept is clear, and then still you have any doubt, then mail me. My email ID is given in description below, or you can comment also, and don't forget to vote for which topic I would make my further videos. So if you like this video, share it with your friends, and don't forget to subscribe my channel. Thank you.